Okay, today we're going to be discussing how to solve solutions for the cosine of theta and for the sine of theta, specifically in a triangle. And it won't necessarily be a right triangle. So take a look, determine the measure of an angle given its sine or cosine, identify and use definitions and theorems relating to sine, cosine, and tangent, and solve real-world problems using the law of sines. In doing so, we will find missing parts of different triangles. So to start this, let's talk about the sine of theta equals k. Triangles do contain angles which measures that are both acute and obtuse. So we're not saying they have to always be right triangles, but they do have also acute and obtuse angles in them as well. Let's review what happens to the cosine of theta and the sine of theta for these angles. All right, we've seen our graphs again. Now notice I am only highlighting the 0 to 180 because we're talking about triangles. So if I ask you to look at cosine and ask yourself what happens to all the cosine values going from 0 to 180 only. And you're saying, well, it looks like they're all different. Truly. Now do the same thing for the sine values. Start looking, oh, it is a slightly different when you're only looking 0 to 180. When you're looking 0 to 180, you're starting to see some repetition. Oh. And one of the angles is acute, and one of them is obtuse. Oh, yeah. Yeah. You know? So you imagine this. I get it. So if you have an angle that says that the sine of 30 is 1/2, then you should also know that the sine of 150 has that same value. So the question is, how are we going to know which angle we're using? And that's where the idea of the supplement theorem comes in. Taking a look, if you have the sine of theta, it always equals the sine of its supplement as well. And so the example I just did, the sine of 30 has to be equal to the sine of 150. If I gave you the sine of 142 degrees, you should know that it's equal to, do the math, 38 degrees. Do the math. So 142 and 38 adds up to give us 180. So we know that both of those would be true. Oh, but the cosine, there's different values all the way through. So we don't have to worry about the cosine. We do have to start worrying about the sine, in other words. How do we know what angle we're dealing with? So here's an example of if the sine of theta is equal to 0.127 and you want to find theta, then you had better think, all right, to undo this, we were doing inverse sine, yep. So inverse sine of 0.127 would give us our answer, right? So try that. Again, make sure your calculator's in the right mode. And you should say, oh, it's a 7 degree or 173 degree. Do the same thing on the next one. In order to solve for theta, we would need to do the inverse sine. Those would cancel then. And on this side, the inverse sine of 0.835. Again, they're not nice ones, so go to your calculator. Theta would have to be 57 degrees or 123 degrees. So if we have two angles there, the question is going to be, well, if it's in a triangle, then how are we going to know which sides? So we have to deal with that. So here we go. In triangle PQR, take a look. We have angle R being 88 degrees. It is not a 90, even though you might say it looks like it. It is not. RQ we have listed as 31 meters, and QP is listed as 150 meters. It says find angle P. So we know right now that this upper left-hand corner, angle P, is where we're headed. So if we're looking for angle P, then we got to go with stuff that goes with it. So example, if I want angle P is to its edge, which is 31, using the law of sines, then I could say angle R, angle R, which we know is 88 degrees, is to its edge, which was the 150. So we could do that math, do the cross products. Okay, we'll set it up. So angle P is what we're solving for. And most of you, yep, the 150 is what we're going to have to get rid of. So go ahead and do the math. And when you do this one, you're saying, well, wait a minute, we're going to do this and do the math. And I'm getting 31 times the 88. And then I have to divide that by 150. So I get about an 18.1-ish or 0.2. 18.2. So P comes out to be about 18.2 degrees. Or you got to be able to say, well, wait a minute, it could also be what? 180 minus that 18.2, which is 161.8. Now the question is, with what we already have, do we have enough space left? So let's do the math. We have an 88. We just got an 18.2. And they didn't say to the nearest, okay, so we're just going to go with 18.2. And then over here we could say, well, we have an 88, and the supplement was 161.8. So your brain has to say, wait a minute, do we have room for that third angle, which is currently Q? So over here, if we took our 88 plus the 18.2, we definitely have room for 106. Sorry, that is 106.2. Okay, so those add up to be 106.2. So we definitely have room for another angle because they have to add up to be 180. But if we start over here and take our 88 plus the 161.8, that adds up to 249, which means we're over, which means no way can that angle of 161.8 be a choice because that's only two angles, the 88 and the 161.8. We need 3 to add up to 180. That's already over in 2. So at this case, we know the 161.8 is out, the 18.2 is still good, and then that should leave us, 73.8 to get us to our 180. So we found angle P, but you want to make sure that you're finding all possibilities. In that case, only one existed, not two, because of the sizes that were given. In this one, we're solving for an edge length. Notice what we have. We have a 30-degree angle. We have two edges. We want little b, but it looks like we're probably going to have to solve for a little c first. And you say, well, how can you tell that? Well, watch. So if we have the 30-degree angle and its opposite side is a 2, we could do the sine of 30 over the 2 is 2. And now we got to do the other one, but the only other edge they gave us was 5, so we're going to have to find the sine of c. And you know what, I'm just thinking on that last one, we only did a regular proportion. We didn't do the law of sines, so scratch that, but I bet you there's still only one angle that exists. Okay, so on this one, let's do our cross products, and let's get things set up. So 2 times the sine of c has to equal 5 times the sine of 30. Let's finish and get the 2 out of there. So that'll just leave us with the sine of c. And we'll solve for that shortly. Let's do our math. we've got 5 times 0.5, because the sine of 30 is 1/2, and that has to be divided by 2. So we're going to get a 1.25 there. Now, if you would continue working on this one and saying, well, I need to get rid of that inverse, well, do the inverse on both sides. That'll cancel. We'll get our C value. But you should notice, some of you might be spotting something here, but go ahead and punch that in. Inverse sine of 1.25. And you should be getting an error. Why? Who's figured that out? Look at this value. How big did we say our sine and cosine values could be if we are in a unit circle? Yes, the range could only be from 1 to -1. This one goes way past that. So what it's telling us is there is no triangle that exists that matches these setups. Okay. Now I'm feeling pretty guilty about that without putting the sine value in, so I'm going to go back to that one. Here we should have had, oh gosh, it comes out to be no. I know that's for a fact, but let's go back and clean up our work here. I'm just going to reset this page for a second. All right, so now we had the sine we need. The sine of 88 is it's 150, as we are finding angle P. So the sine of angle P is to 31. Okay, so the sine of 88 is to 31, so we got that multiplied out front, has to be equal to 150 times the sine of angle P. All right, we divide by the 150. We're going to use sine values. Okay, the sine of angle P. So the sine of angle P, let's go 31 times the sine of 88, close your parentheses, and divide that by 150. And now we have to do inverse sine. And we're getting about 11.9. So our number's a little different. So we're getting angle P is approximately 11.9-ish, almost 12. And so if it's 11.9, do the math again. 180 minus 11.9 would give us about 168.1. But I do believe, for the same reasons we had before, if you take 88 and 168.1, you'll be over 180. So no choice there. But over here, if you take 88 and 11.9, you're still going to have room. A 99.9, you're still going to have room for another angle to still equal 180. So you'll have one triangle, one angle that does work in this situation, not two. All right, with my error cleaned up there, you will have to test whether you have one or two possibilities. Okay. Bring any questions you might have to class.